Crude oil is a mixture of lots of different chemicals, and some of those are called alkanes. So we're going to look at those today. Alkanes are basically, well, they're a type of hydrocarbon, and the word hydrocarbon means literally just carbon and hydrogen. There's nothing else there. So the definition that you need to be able to give for a hydrocarbon is that they only, and that word there is really important, only contain carbon and hydrogen. So here's 6 different chemicals, and if you pause and have a look at the definition and have a look at them, you should be able to eliminate some of them which are not hydrocarbons. And they're fairly obvious. We have one which contains an oxygen atom, and that's this one here. And we have one which contains a nitrogen atom as well, and that's this one here. The rest of them are hydrocarbons, but they're not all alkanes. We need to go a little bit deeper. So alkanes are made from carbon and hydrogen only, and we know that those are both non-metals. So because they're non-metals, they will form covalent bonds. Now, if you remember, carbon has 6 electrons from the periodic table, and it has therefore 2 electron shells. The innermost electron shell only fits 2 electrons onto it, and the outer shell fits 4 electrons, giving us our total of 6. Hydrogen has only 1 electron shell because it only has 1 electron. So we have that in that one shell. So if you remember from our introduction to bonding topic, to make a covalent bond, we have the overlap of atoms so that they can share a pair of electrons. And so if I take my hydrogen atom and I overlap it with the carbon atom, you can see that the hydrogen has 2 electrons in its outer shell now because it's sharing, and the carbon now has 5. Now that's great for the hydrogen because we know that 2 is the maximum number of electrons that we can have in a hydrogen atom's outer shell, which is the first shell, and so that is now stable. But the carbon atom needs some more sharing to happen in order to make it stable, because the second shell contains 8 electrons as a maximum. So we've got 5 there at the moment. So if we share one more hydrogen, we get 6, and then one more hydrogen, we get 7, and finally, if we put the last hydrogen on, we can make CH4. We have full shells on all of the atoms. That makes it very stable. And so this is how the introduction to bonding topic is related into this lesson. So from the introduction to bonding topic as well, you might remember that there's a simpler way of drawing this to show just the bonds without really worrying about where the electrons are, and that's by using the displayed formula. And methane, we would show the displayed formula like that. This is CH4 methane. So that's a little bit of recap. The next thing that we need to know is that an alkane is saturated, and the word saturated means that we can't really fit any more hydrogen into the molecule, kind of. Basically, the reason for that is because there are only single bonds in the molecule. Now, we know that double bonds exist, and in some of my examples, I had some double bonds, but in an alkane, there are no double bonds. They are saturated. So here are my remaining compounds. You can eliminate a couple more which are unsaturated. And the ones which are unsaturated are this one. You can see there's 3 double bonds there, and then underneath there we have this one as well. That has a double bond in it as well. So the only ones left are top left and bottom right, but only one of those is an alkane. There's some more detail. So they're hydrocarbons and they're saturated. We need to just have one more piece of information. So let me just show you what these alkanes would look like. We have a displayed formula of the first one already. I told you that was the first one. That's called methane. And its molecular formula is CH4. We can see that. 1 carbon, 4 hydrogens. If we look at the next one up, the next one actually has 2 carbon atoms. This is also an alkane, and you can see it has 6 hydrogen atoms. So we get the molecular formula C2H6. If we add another carbon atom, we get another 2 hydrogens attached, and so we end up with C3H8. And so on. We can do this we can do this and do it over and over and over again until we get to something like C60 that exists. C60, that would be C60H122. But there is a pattern here, because every time we go up by one carbon atom, we go up by 2 hydrogens as well. And basically the reason for that is that for every carbon atom we put in, we end up with 2 extra hydrogen atoms. But there's also one on the end and one on the beginning of the molecule. So there's twice as many hydrogen atoms as there are carbon atoms, plus 2. And for any alkane, that's true. So the formula of an alkane can be shown to be Cn, where n is a number, H, twice as many as that number, plus 2. So 2n plus 2. Okay, so C1 for methane would be C1, H, 2 times 1 is 2, plus 2 is 4, CH4, and we can see that fits for all of these. One last thing, we need to be able to give names for these, and the names of these are important because actually there's a logical naming system that we use where the start of the name gives us the number of carbon atoms. Now I've already said that the first one was methane, and the meth there actually means it's made with 1 carbon atom. And the ane bit at the end is also important. We finish with ane to show that it's an alkane. So methane literally means a 1 carbon atom alkane. And the next one means a 2 carbon atom alkane, and that's called ethane. And the next one would be a 3 carbon atom alkane, would be propane. So prop means 3 carbon atoms, eth means 2, meth means 1. And the final one that you need to know for your GCSE is bute. It's not but, butane, which is 4 carbon atoms. Now, I could change the ending of this for a different chemical. So you might have heard of ethanol, and that means it's got 2 carbon atoms, but it's actually an alcohol, which is what ol means. For alkanes, they all end in ane, and ethane means it's 2 carbon atoms and an alkane. So you should be able to look at this and pause the video, just check the formula of the remaining 2. You can work out which one is the alkane, and you should be able to name it. So CnH2n plus 2, if we look at the top left, we can see that there are 6 carbon atoms and 12 hydrogen atoms, which means that we don't have twice as many plus 2 hydrogen atoms as carbon atoms. We in fact just have twice as many. So that one is not an alkane, whereas the bottom right one, we have C3H8. The word for 3 carbon atoms is prop, and it's an alkane, so the bottom right is propane.